Hello everyone. Today we are going to continue working with polynomials and learn how to divide them. So, how do we divide normal numbers? Well, let's imagine that we want to divide a number 25 over 4. Well, we know that 25 is kind of 24 plus 1, right? And if we divide it over 4, we can write it down like this: 24 over 4 plus 1 over 4. 24 can be divided over 4, and that's going to give us 6, right? And over here, we are going to have leftover of 1 over 4. So what is what over here? Let me change the color. So what is 25 here? 25 here is dividend. Divided by, right? What is 4 here? Divider. Uh, 6 quotient. And 1 over here on the top is a remainder. Okay. Well, kind of, you have a fraction 25 over 4. We can always represent it as 6 and 1 over 4, right? Well, there is another way to kind of deal with this division of 25 over 4. Actually, if I write down 25 over 4 as 6 plus 1 over 4, and then multiply here by 4, and multiply this expression by 4, I'm going to get, here 4 and 4 is going to be canceled, 25 represented as 6 multiplied by 4. Plus, if I multiply 4 by 1 over 4, I'm going to just get 1, right? Well, this is another way to represent 25. Still, 25 is dividend, 4 is divisor, 6 is a quotient. I'm going to kind of label them dividend. 6 is a quotient. 4 is a divisor. And 1 is a remainder. Okay. Now, how do we divide polynomials? Exactly same way. I'm going to write down division of polynomial p of x over a polynomial d of x. Well, p of x is going to be dividend. D of x is divisor. And the result of this is going to be equal to a quotient q of x plus a remainder r of x divided over d of x. If you compare it with my first line, that's like p of x is like 25, d of x is like 4, and the quotient is 6, so q is 6, and the remainder is 1. Well, same way, if we multiply this expression by d, if we multiply it by d of x, both sides, we are going to get expression p of x equals q of x by d of x plus r of x. Guys, sometimes we will use this shape of representation of division. Sometimes we are going to use it like a fraction. I'm going to usually tell you which way I want my answer. Okay, now let's try to divide something. I'm going to start with division. First example is going to be division of x squared minus 4x minus 5 over x minus 1. Well, what I'm going to do, guys, I'm going to write it down like this, like we usually do with numbers. I'm going to write out x squared minus 4x minus 5 here, x minus 1 here. It's like I would write down over here like 25 and the 4 over here and start thinking, okay, how much what I'll need to get kind of satisfy 25. Well, I'll need 6, right? 4 by 6 is 24, and then I'll subtract and get 1 over here, right? That's like a simple way of writing down this division. I'm going to do the same with polynomials, just by what I'll need to multiply this x to get x squared. Well, by x, right? I'm going to multiply it by x. What does it mean? I'm going to have x by x, which is x squared, right? And x by -1 is minus x. Now I'm going to subtract it like usually I do over here, right? Well, x squared minus x squared is 0, minus 4x minus minus x. It's like because we are subtracting, there are two minuses. It's going to give me minus 3x, and I'm going to bring minus 5 down. Oh, it looks like we divide bigger number here. If we do it, then we are going to have something more complicated. Okay. Well, I'm going to put something here just to make sure that it's clear. Something like this. So I kind of have something happening like 5 minus 4, right? It's 1, and then I'm bringing this 3. And then I repeat the process. I'm going to search like what is going to be kind of very close to 13, but a little bit less. Looks like 4 multiplied by 3 is going to be a little bit less than 13, right? It's going to be 12, and you do subtraction again. Here we are going to have what? What we need to multiply x to get minus 3. Well, by minus 3, actually, minus 3x is going to give us minus 3x minus 3 by x. Minus 1 by minus 3 is going to be what? Just 3, right? And just minus by minus is plus, and 1 by 3 is 3. Now, if I'm going to subtract these two expressions, remember that we always kind of subtracted. Minus 3 by minus, subtract minus 3 is going to give me 0. Minus 5 subtract 3 is going to give me minus 8. Right? So, well, I'm done with my division. What I can do? Now I can write down my result like this. The quotient, this is my quotient. This is my q of x. I'm going to write down x minus 3. This is my remainder, r of x. Well, it doesn't have any x, but can have x, like, you know, I'm going to write plus minus 8. And my divisor is the same number. It's not the same polynomial, x minus 1. So that's one way to write it down. And if I want to use this form, I'm going to write down that x squared minus 4x minus 5 equals x minus 3 by x minus 1, right? The quotient, which is x minus 3, divisor x minus 1, and remainder is minus 8. You don't need to write down like plus minus 8. I'm doing this to show that remainder sometimes going to be positive, sometimes negative. Okay, so this is kind of simple division, and we know how to do it. Now we will try something a little bit more complicated to practice. So example number 2. I'm going to divide x cubed minus x squared plus 2x over x squared plus 1. Well, again, I'm going to write it down a standard way. So usually I write down x cubed minus x squared plus 2x. Well, I don't have the last term here, which has no x. I'm going to just write down 0 here. If you don't have a term which corresponds to a certain power of x, for example, you're missing x squared term in your polynomial, then you just write down 0 multiplied by x squared, because eventually it's going to help us. Over here, I'm going to write down x squared plus 0x plus 1. Again, why I'm doing this? Because I want to have like powers of x like orders in my normal numbers. So these are hundreds, these are tens, and these are ones. So here, ones like tens and hundreds. So I put a coefficient 0, so actually it's still going to be x squared plus 1, but with extra middle term. Now I'm going to start thinking, okay, what should I multiply x squared to get x cubed? Just by x, right? So x by x squared is x cubed. X by 0x is going to be plus 0, and x by 1 is going to give me just x. Now I'm going to subtract. Here nothing happens. Here I subtract 0, it's going to give me minus x squared. Here I subtract x, it's going to give me just x, and I bring this 0 down. By what I'll need to multiply x squared to get minus x squared? Well, by minus 1, right? So I'm multiplying everything by minus 1x squared, and over here is going to be 0. Well, it's supposed to be minus 0, but makes no difference. But I think I should still write down minus so you can kind of see better. Minus 0x. and minus 1. I'm going to subtract everything and get 0 here, x over here, right? Because x minus or plus 0. And 0 minus 1 is plus 1. So my result is going to be my quotient, right? And that's going to be my remainder. I'm going to write out x minus 1 as my quotient plus x plus 1, and my divisor is x squared plus 1. So I'm going to put it over here. That's going to be the result of my division. How do I know that I should stop dividing after I get x plus 1? Well, guys, you see that for x plus 1, there is nothing you multiply by x squared and get just x. You basically have to divide x already. So it's like you are continuing division after decimal point. We're not going to do this for polynomials. If the degree of your remainder is less than degree of your divisor, you stop division. For example, degree here is 1, and 1 is less than 2, which is over here, right? And this is like 1 over here. So you start thinking that this is remainder. I'm going to consider kind of ask you to solve something for me. So some self-work. Problem 1. 6x cubed plus x squared minus 12x plus 5 divide over x 3x minus 4. Okay, let's try to do this. In the second problem, polynomial 2x to the power of 4 minus x cubed plus 9x squared divide by x squared plus 4. I'm as usually going to count to 5 and then I'm going to solve it, but I suggest you to stop my video and do it on your own, okay? So 1, 2, 3, 4, 5, and I'm going to start solving these problems. So let's do the first solution. So for the first polynomial, let me label that it's problem 1. I'm going to write down 6x cubed plus x squared minus 12x plus 5. All powers of x are represented here, so I don't have any zeros. Here I'm going to write down 3x minus 4. And we'll start this process of division. By what I'll need to multiply 3x to get 6x cubed. 3x multiplied by something to get 6x cubed. Well, at least I'll need x squared, right? Because I'll need to get x cubed from x. And then 3 by what is 6? It's by 2, right? So now I'm going to do this multiplication. 2 by 3 is 6, and this is x cubed. And then minus 4 by 2x squared is going to give me minus 8x squared. Now I'm going to do subtraction. Well, usually the term you're trying to eliminate will be eliminated. Here we are going to have x squared minus 2 minuses, this one and this one. So they're going to give me plus, and I'm going to get 9x squared. Moving this minus 12 down, minus 12x down, I'm going to continue. By what I'll need to multiply 3x multiplied by something to get 9x squared. What I see that it's supposed to be at least x. And 3 to get 9, I'll need to multiply by 3x. That's what I'm going to do. So 9x squared, I'm multiplying 3x by 3x. Minus, and 4 multiplied by 3 is 12, right? And x over here. I'm going to do subtraction. Well, I'm very lucky. When I subtract everything, I'm just going to get 0 here. 0 here and 0 here, right? And I'm going to move this plus 5 down. And because the power of plus 5 is just 0, because it's multiplied by x to the power of 0 less than like this 3x minus 4, the power is 1, the highest power, I'm going to say that this is my remainder. So here I'm going to write down that remainder equals 5, and the quotient is whatever sits on the top. That's going to be my quotient. Quotient equals 2x squared plus 3x. That's it. So I kind of did a division. If you wish to write it down as a fraction, you are going to write down the quotient plus remainder divided by 3x over 4. Well, maybe I should do this. So it's 2x squared plus 3x plus 5 over 3x minus 4. That's going to be the result of the division for this problem. Okay, and let's move to problem 2. Here, I'm going to kind of make a more complex division. So let me copy everything. 2x to the power of 4 minus x cubed plus 9x squared. We don't have a first power of x. I'm going to write down 0x. And the last term is going to be 0, the free term. Here I'm going to write down x squared plus 0x plus 4. Again, if you don't write it down, it's not going to give you a mistake, but maybe you're going to be a little bit confused on where to put that product of x squared by something. So by what we'll need to multiply x squared to get x to the power of 4? Well, by x squared, right? And we have coefficient 2 here, so it's going to be 2x squared. So it's 2x to the power of 4 plus 0. And 4 by 2 is 8x squared. Doing subtraction is going to give me, well, here is 0 subtracted, it's going to be minus x cubed. 9 minus 8 is going to give me just x squared, and this is going to be 0x. Next step, by what I'll need to multiply x to get x cubed? Well, by x, right? X by x squared is going to give me x cubed. Because I want to have a minus here, I'll need to multiply it by minus x. Because if I multiply minus x by x squared, I'm going to get minus x cubed. 0, the middle term, and minus 4x. And I'm going to do subtraction. So 0 here, x squared here, and here we are going to subtract, well, this is 0x, right? 0x is actually 0. If we subtract minus minus, we are going to have 4x. Okay, and I'm bringing the last 0 down. By what we'll need to multiply x squared to get just x squared? Oh, just by 1, right? So I'm just going to copy x squared plus 0 plus 4 over here and do subtraction. Here I'm going to get 0. Here 4x, because I'm kind of subtracting nothing. And here I'm going to get minus 4. Why? Because we are subtracting, right? There is a minus here. Well, I think I'm done with my subtraction. So my polynomial here has a degree 1, right? My polynomial here has a degree 2. So this polynomial has a smaller degree than this one, so I'm done with process of division. This is my remainder. Well, again, if you want to write down your answer in the quotient is whatever sits over here, that's a quotient, right? Plus 4x minus 4, and in denominator you have x squared plus 4. You copy divisor. Well, you don't need to copy 0. 0 is just to range division, actually. Okay, so perfect. Now, guys, if you are dividing by something simple, like we were doing over here, for example, by x minus 1, there is actually easier way to write down this division, shorter way. Usually you use the shorter way when your polynomial which you are dividing is really long. For example, here it's a quadratic polynomial, right? It has only 3 terms, x squared minus 4x minus 5. But if your polynomial is long, like a 7-degree polynomial, and has like, I don't know, 6 terms, writing down subtraction of each term is going to give you a long process. So this division is called actually long division. We also have short division. Short division is called synthetic division. I'm going to teach you how to use synthetic division. But if you don't get synthetic division, I'm not going to ask you to perform anything specifically by synthetic division. If you learn long division, that's going to be enough. But if you learn synthetic division, that's going to be kind of advantage. What I'm going to do, synthetic division. Sorry. Short division. Well, what I'm going to do, guys, I'm going to do the very same division I did like over here. I did over here, but I'm going to do it shorter way. I'm thinking maybe I can kind of cut and copy something. Because I really need to do comparison between these two divisions. Don't want to pass it. Maybe it passed it over here already. Yes. Well, that's a bit strange to me. Okay, no, guys, I don't really know how to kind of move the stuff around. So I'm just going to actually show it second time. So I'm going to divide x squared minus 4x minus 5 over x minus 1. One more time. So I'm going to show you how long division is going to compare to a short division. So usually short division is x squared. You copy here, you copy here, right? And then you look, okay, but what we multiply by x, we get x squared x, right? So it's x squared minus x. Subtract, and you get what? 4 minus, that's 3x, right? Minus 5. And you're thinking, okay, x, minus 3x. So you will need to multiply. You'll need to multiply x by minus 3 to get actually minus 3x, right? And plus 3 here, and you subtract, and you get like minus 8. How? This is long division. I'm going to label it long. Here it's going to be short. On short way, how it's going to look. In short way, guys, we are just going to copy the coefficients of the powers. Like x squared has coefficient 1. X to the first power has coefficient minus 4, and like free term has coefficient minus 5. Over here, guys, we are going to copy whatever is subtracted from x. This minus 1. Actually, go back and just circle it. We are going to copy 1 here. How the process is going to work? Let me move up. I'm going to draw a straight line here, and I'm going to move this first one down here. Then I'm going to multiply this 1 by 1, which is going to give me 1, and put it under 4. So I'm going to put it here. Sorry. Here. Now I'm going to add these two things and get what? Minus 3. I'll take minus 3 multiplied by 1 and put the result over here. Minus 3 by 1 is minus 3. And if I add them, I'm going to get minus 8. Now that's much shorter than this, right? So what is going to be minus 8? Minus 8 is going to be a remainder. What is this? That's a quotient. Quotient here is going to look like this. It does not have any x, but actually we are going to kind of add x over here to 1. We are not adding, multiplying actually, minus 3. Well, kind of the numbers over here are going to be converted back into polynomial. Remember, we had a polynomial x squared minus 4x minus 5, right? We converted it into 3 numbers, 1 minus 4 minus 5. Now we take the result and convert it from numbers back to polynomial. And you're going to see that 1 multiplied by x minus 3, it's actually x minus 3. That's exactly the quotient we got over here. So that's called a short division, synthetic division. When it works when you have x minus some number. Can be plus some numbers, and you kind of are going to consider it as x minus negative number. But otherwise, that's how we perform short division. So one more time, you bring this 1, the first number you have down here, and then start doing multiplication. Multiply 1 by this down number and copy the result here. And then add it to the top number, minus 4 plus 1 minus 3. By the way, this minus 3 is this one. And then you multiply 1 by negative 3 and again copy it here. and then add it to -5, and that's going to be the end of the process. I think short division is not very like clear or transparent, and you'll need some practice to do it. I'm going to actually give you one more example of this synthetic division, okay? So I'm going to divide a polynomial 3x to the power of 5 plus 5 x to the power of 4 minus 4x cubed plus 7x plus 3 over a polynomial q. Oh, I should write down d actually, right? Polynomial d x plus 2. So watch one more time how we write down the synthetic division. First, you copy the coefficients. 3, then goes 5, then goes -4. If you have a minus, you copy it. Then there is no x squared. I'm going to put 0 here. No x squared. Then goes 7, and the last one is 3. What I copy here? Well, it's x plus 2. I'm going to represent x plus 2 as x minus -2. And I'm going to put here -2. And now I'm going to start the process. So first, I'm going to copy 3 down. And then -2 by 3 is -6. Copy -6 here. Add them up, -1. -2 by -1 is 2. Copy here. Add them up, -2. -2 by -2 is 4. Add them up, 4. And -2 by 4 is -8. 7 minus 8 is -1. -2 by 1 is just 2. 2 plus 3 is 5. And I'm done. So this is going to be my remainder. This is going to be my quotient, but I'll need to add access to this quotient. I'm going to do it in like red color. So you don't add anything to the last term because it's a free term, but x over here, x squared here, x cubed here, and x to the power of 4 here. So that's going to be the result. The quotient here, the quotient is going to be 3x to the power of 4 minus x cubed minus 2x squared. Well, I'm going to put plus here because actually they're not multiplied, -1, right? And remainder is going to be just 5. See? Okay, looks good. Now, one more last thing I want to talk about is a remainder theorem. Because remember when we had this long division, this one was a simple x squared minus 4x minus 5. We could write down the result of this division like this. X squared minus 4x minus 5 equals x minus 3 by x minus 1 minus 8, right? I'm still trying to learn how to not allowing me to paste actually. How do we paste here? That's not why I want. Okay, guys, I'm going to just write down the result. I kind of remember it because I did it already 3 times today, right? So x squared minus 4x minus 5 is equal to x minus 3, that's a quotient, right? That's a quotient. X minus 1, that's a divider. And, sorry, minus x, which minus 8, which is a remainder, right? Now, what is going to happen? And that's my polynomial, p of x, right? What is going to happen if I plug in instead of x here, the 1, actual solution of my divider? Well, if I plug in 1 here, what happens to this? Well, this is going to be 0, and I'm going to just kind of multiply this by 0 and get a remainder, minus 8. So actually, polynomial at, if I divide like the theorem sounds next. If R is a remainder of division of P of X over X minus C, you get here a quotient and a remainder. Then what is going to happen if I plug in this C into polynomial? Well, I'm just going to get this remainder because of the structure of like the polynomial can be represented as quotient by divider minus remainder. If I make a divider equals to 0, then the quotient is equal to the polynomial is equal to remainder. So I'm going to write down polynomial at point C. The root of your divider is going to be equal to your remainder. Well, in our case, minus 8. How it helps? Usually we are not going to find the remainder or what is polynomial by just kind of finding remainder. You can always plug it in, just literally. You can just put 1 here. 1 squared minus 4 by 1 minus 5. What is going to be? Well, negative 8, same way. You plug into polynomial, you get minus 8, or you find the remainder, you get minus 8. Well, of course, it's much easier to just plug into polynomial, right? You just take a calculator, plug into polynomial, get this minus 8 instead of doing the division, right? But how it helps us knowing this fact? Well, imagine that I'm going to write down how it helps. Imagine that we have a polynomial x equals x cubed minus 7x plus 6. And imagine that we plug in 1 into this polynomial. It's 1 minus what? 7 plus 6. So what is going to be the result? 0. So actually, now I know that if I divide P of x, which is, well, I'm going to write it down actually. If I divide x cubed minus 7x plus 6 over x minus 1, this one, I'm supposed to get some quotient, which I don't know actually, plus remainder is going to be equal to 0. If I represent this polynomial in a line form without a denominator, if I represent it like this, minus 7x plus 6s quotient by x minus 1 plus 0, I'm going to see that, well, if my remainder is 0, then my polynomial can be represented as a product of two polynomials, right? This is like polynomial, which I don't know, but I can find it by dividing. And this one I just do know because I'm dividing by 8. But what I did, I factored my cubical polynomial. Well, this is called a factor theorem, actually. The ability to factor if remainder is equal to 0. Factor theorem. If, remainder, let me write it. If you divide P of x over x minus c and remainder equals to 0, then P of x can be represented as some Q of x multiplied by x minus c. Well, we just like normally we write down plus remainder, but because it's 0, you don't write down nothing. Well, actually, it's allowing us to factor x minus c out of polynomial. Degree of polynomial q is going to be lower than polynomial p. For example, for cubic polynomial, q is going to be a quadratic one, which is kind of easier to factor further, right? Let me give you kind of an example or like some self-work maybe to factor. Somebody is giving polynomial P of x, x cubed plus 2x squared minus 3x minus 10, and they are asking you to factor x minus 2 out of this polynomial. I'm going to count to 5. You try to do it on your own. So basically, you need to divide this polynomial by this x minus 2 and get like the result. And the result is going to be another polynomial, but lower degree. And we are going to factor actually this parenthesis. Okay. So I'm going to count to 5. You stop my video and try to do division on your own. Okay. You can do long division or synthetic. I'm going to perform actually synthetic division to practice a little bit with synthetic division. But normally long, if you learn one of these two divisions, that's going to be fine with me. So 1, 2, 3, 4, 5. And I'm going to solve it. Yeah, guys, I'm going to do synthetic division. But again, if you like long division better, you can always do it. For synthetic division, I'm going to copy the coefficients. That's 1, that's 2, and that's what? -3, and that's -10. X minus 2 is going to produce 2 over here. I'm going to draw a line here and copy 1 down. And 2 by 1 is 2. Add them up as 4. 2 by 4 is 8. Add -3 and 8 is going to give me 5. 2 by 5 is 10. And add 10 and -10 is going to be 0. So my remainder here is equal to 0. So it's actually a factor. What kind of polynomial is quotient? It's 1 by x squared plus 4x plus 5. And you can write down that your x cubed plus 2x squared minus 3x minus 10 can be represented as x squared plus 4x plus 5 multiplied by x minus 2. Well, you're supposed to write down plus remainder, right? But we know that remainder is equal to 0. So we don't have it. Well, can we factor this further? Yeah, we can. We can try to factor now this expression. What is this expression? I think it's supposed to be probably x plus, maybe not that easy, right? I'm going to probably try to factor it. It's not going to be probably super easy. X1, 2, I'm going to use the formula. Minus a square root 4 is 16, right? Minus 4 by 5. I see it's a complex root. Okay, guys, in real numbers, we are not going to be able to factor it, but let's show this. Minus 4 over 2 by 1. You see, well, unless I did a mistake somewhere, it doesn't look like I did a mistake, but who knows? I see that that's 1, 1, 2, 2, 4. Well, it doesn't look like I did a mistake anywhere. So we see that we have number 16 minus 20 under the square root, which is going to be minus 4, right? Less than 0. So we have no real roots. Well, no real roots means that we're not going to continue factoring it. We are going to keep it as it is, okay? We factored just x minus 2, and that's going to be enough for us. Okay, usually, guys, I'm not going to give you problems which you won't be able to solve. So if I ask you to factor completely something, I'll manage to give you a polynomial or like quadratic polynomial which you can factor. I did copy this problem from the book, and I was not very careful with picking up the problem, I guess. Okay, that's all for today. And please do the homework one more time. Yes, even if it's too long to enter everything online, at least do it on paper. When you have time, enter your answers online. And if something doesn't work, let me know and we'll try to fix it. Okay.